Today we're going to run Dolly version 2. Dolly is a instruction following large language model which is trained, or specifically say is tuning, the PATIA 12b foundational large language model. It is trained on 15,000 instruction fine-tuning records which are generated by the Databricks employees in domains like brainstorming, Q&A, classification. So that's very impressive. It has the added benefit that the way how the dataset is obtained, that the underlying model is also open source. It now has a license that provides you the ability to use the model for commercial purposes. And if you like, you can also retrain the model with your dataset or add to the existing dataset. I prepared 2 notebooks. I run them on Oracle Cloud, and let's see how the model is going to perform. So to be able to run the models, first we have to install PyTorch. In Oracle Data Science Notebooks, Conda is already pre-installed and configured. So everything we have to do now is just to install the PyTorch Conda environment. So let's go for it. Click on this plus icon and then select the Environment Explorer. From architecture, we're running on GPU. So we need to install this here. Just open it. Copy the install command. From the Launch Explorer, you can click to open a terminal. Once the terminal is open, just paste this command here and hit enter, and it's going to install the PyTorch Conda environment. It takes a minute or two to install the Conda environment. In the terminal, you can execute the no Conda CLI. Now what we need to do is to activate this Conda in the terminal. So copy this path. Say Conda activate, paste the path there, hit enter, and now we are in the Conda environment. In the Databricks documentation about Dolly, it says that we have to install accelerate and transformers for Torch. A good practice is that you create a requirements file and then put the libraries inside. Then go back to your terminal, make sure that you are into the folder where your code resides and where your requirements file is, and then install the requirements using this line. This will make sure that the libraries will be installed just as specified in your requirements file. This is done. So now we should have everything we need to run Dolly. So let's go into our notebook. Here on the top right, make sure that you select the Conda environment that we've just installed. Click select, and we can now start executing the cells one by one. So let's run the first cell. You can either run it by clicking on this icon here on the top, or use shift and enter once you're on the cell. So this is going to take now a little bit time. We need to load the model. If you load the model for the very first time, make sure that you're patient. It takes about 2 to 3 or 4 minutes, depending on how good your internet connection is. The model is about 24 gigabyte large. Now the model is loaded, and we can send the first question to the model and see what it's going to generate. So the first one is explain to me the difference between nuclear fusion and fusion, and we get our first response. Now there is also another way to load the model. This is the second notebook example that you will find the link in the description to this video. This method is also shown in the public documentation from Dolly. It allows you to separately load the tokenizer and the model. You can also save the model locally if you want. And then you have to check out the instruction text generation pipeline function. So how to check out this function? Well, first copy the URL here, go into your terminal, make sure that you are into the folder where your code is, and just say git clone. And this is going to clone the code. And if you look here on the left side, you will see that you have a folder which includes the Python file that has the functions and the class that it's required for the second example. In my case, I renamed the folder to Dolly so that it's easier to use. And when I go to the notebook, I just modify the import so that I have now dolly.instructPipeline, where Dolly is the name of the folder where the code resides. So now I can start executing those cells, but before that you have again to go here on the top right and select the Conda environment, and now you can run the cells. So we are loading the tokenizer, now the model. Here again, if you load the model for the very first time, it could take a little bit time. So now we can start setting instructions to the model and ask him for responses. So let's try again the same question like we tried before, and we got our first response. Now something I've seen that all models failed so far, at least the one that are publicly available, is when I ask him to tell me if 15 is a prime number. I don't expect this model to perform better here because it's just not tuned for that, but let's try. I've noticed also that it takes considerable amount of time to generate a response. Even though this is a powerful machine, I'm having 2 NVIDIA A10 GPUs on this instance running, and also a large amount of memory. So it's definitely not like this machine doesn't have enough resources to run this model. And it says again, yes, 15 is a prime number, very unfortunate. And this one is very funny. It is prime because it's a greater than 1 and smaller than 100. And that description is not really right, unfortunately. So it's close, but it's not correct. So let's ask him to write a Python function that detects if a number is prime. Let's see how this is going to work. Again, as I said, I don't expect that this is going to work well because it was not tuned for that, but let's see. All right, we have our response here. I ran that before, of course. So it looks like the response this time is a little bit different. So you can use print out to have a better formatting. Well, this didn't go very well. The previous time I tested, the response was better. Something that I've seen in the dataset is that when they tune it, they had this instruction, which is the question, and then the context. So I would like to change this and say, please write a Python code that checks if number is prime. And as a context, I'm going to provide the previous response. I also set time so that you can see how much time it takes to generate the response. It's quite a lot. It's slow. GPU seems utilized. Memory utilization is very close to the max. Well, that was interesting. That's something that I didn't expect it. I'm not sure I understand what it tries to do. Maybe my context is not really okay. Let's move on. I have another file here which describes the top benefits of the Oracle Cloud. It's a public information. I took it from the website. So I would like to load this text, and then I would like to ask the algorithm to summarize the most important information inside. We are going to load the file with the entire text inside. And then first I'm going to try vanilla like this. Could you summarize the Oracle Cloud benefits and why we should use it? Just without providing any context, anything, to see what's going to happen. All right, it provided a kind of a generic response, so I don't think it's okay. So I have 3 cells with 3 different ways. I would like to try to see which way works better. So the first one is I have the same question and I just provide here, I set context, and the file content is the content of the file that we just read previously. So let's try this first. I've noticed that I made a mistake with the time parameter here, so I need to change that. It has to be like this. So this response looks okay, actually. It's very generic one. I'm not really sure if it was able to use much of the text that I've provided, but it's not bad. Let's try the next one and see how this one is going to look like. It's the same question, but here I just said use following description as a context, and then I provide the entire content of the file. So let's see how this is going to go. And I'm probably going to execute the last one as well, and then we are going to see the results from all of 3 at once. The last one is a little bit different type of question. I just said summarize the top 5 benefits of using Oracle Cloud from the following text, and then I'm providing the text. The last one is interesting to see if it's going to pick up exactly what it is in the text, or it's going to hallucinate. Okay, as you can see for this one, it took about 46 seconds to generate a response. Okay, the last one is done as well. It took about 34 seconds to generate the response, and very interesting, I think it was able to pick up the top 5 benefits. If you just copy one of those and go into the text and search, you'll see this is there. Instance business insights. Yeah. Centralized data security. Wow, this looks really very good. Very impressive. It definitely performs very well when it comes to text summarization. This response is interesting. It was able to pick up important stuff from the text, but at the same time it was putting some stuff inside, like first tells me thank you, and then the next one is greener, which I don't know where this is coming from, so that's kind of a strange. Okay, bonus one. Let's try one more thing, which is I'm gonna ask him to write a sales pitch to a large enterprise corporation on the benefits of using Oracle Cloud using the following text. So let's see how well this is gonna go. Okay, we have our response, and it's definitely not what I expected. It doesn't really look that good, unfortunately. So if you try questions that are close to the questions that are used for the tuning the algorithm, it's going to work okay. I guess it's what was tuned for this kind of tasks, and as such, as you can see, it's not really performing that well. I guess you can just go through the data set that was used to fine-tune the algorithm, identify what type of questions will work okay. And then if you provide them also additional context, like you've seen when I asked him to identify the top 5 benefits of using Oracle Cloud from existing text, this was actually working very well. Okay, that's it for today. I hope you learned something, and I will see you next time.